Hi, everybody. So today we're going to talk about changes in rate of change or changes in your slope. Okay. What happens to a graph when we change our slope? Yesterday's video talked about changes in our Y-intercept and how that affects our graph, our linear functions. So today we're looking at changes in slope and how that affects our graph. Okay. So if you will recall, the linear parent function is y equals x. Okay. Now we can write it as f of x equals x, and that's the same thing. That's just the function notation for it. Okay. If we want to create other linear functions, we could do that by changing the slope or the y-intercept. Now in previous video, we changed the y-intercept of the parent function and found that that will move the line up or down depending on whether or not that y-intercept is positive or negative. So today we're going to look at changing the slope and how does that affect our graph. Okay. So our first example says to graph f of x equals x and g of x equals 4x on the same coordinate plane below. So we're going to go ahead and graph the parent function. Okay, remember the parent function is this f of x equals x as our linear parent function. So we're going to graph that first. So that starts at 0, 0 and has a slope of 1 over 1. And so you're just going to go up 1 and right 1 until you get to the end. And then when you get to the end of that first quadrant, you can go back to the y-intercept and then go down 1 and left 1. And that will just do that until you get to the end of the third quadrant there. And that is your linear parent function. And I'm going to try to do this a little more on my points here. Straight enough. We're going to call that straight. All right, so f of x. Probably would have been straighter if I wasn't trying so hard. There we go. All right. I'm going to go ahead and put it over here on example 2 because we're going to want our parent function on there as well. And just a reminder, anytime that you are graphing more than one function on the same graph, you want to go ahead and label them so we know which function is which when we're looking at it. You may know which function is which, but if you are showing it to someone else, then they need to know which functions you are graphing on that graph as well, on that coordinate plane. So again, our linear parent function is f of x for right now. Okay. All right. So because we're changing slope, we want to really look at our slope number here, and that's 4. So our slope is 4. Now we don't have a y-intercept added onto it, so our b value, when we look at the y equals mx plus b function, is 0. Okay, so that means that our y-intercept is at 0, 0. I'm going to go ahead and mark that point as our y-intercept. Okay, and from there, our slope is 4, which means it's really 4 over 1. So if you will recall back to when we've talked about slopes before, we have a positive slope, okay, then we want to move up in a positive direction and then right in a positive direction. Once we've run out of space in that way, that direction, we can go down in a negative direction and then left in a negative direction. And that will give us a positive slope overall. Now, conversely, if we are looking at a negative slope, which we'll see an example of that here in a little while, if we're looking at a negative slope. Our negative slope starts with going down in a, you know what, I have the wrong slopes there. Give me just a moment. I drew it wrong. Here we go. Negative slope goes this way. There we go. And so we go down in a negative direction, and then we'll go right in a positive direction, because if you recall, negative rise over positive run still gives us a negative slope overall. We have a positive rise and a negative run. Again, positive rise over negative run, we're still going to get a negative slope overall. Okay, so we have 4 over 1. It's a positive 4 over 1. So we're going to go up 4 units. So 1, 2, 3, 4, and then right 1. And we're going to do that again. We're going to go up 4 and right 1. And I don't have enough space to go up 4 again. So now we're going to go back to our Y-intercept. This time we're going to go down 4 and left 1. And then down 4 and left 1. Okay. Now, you want to be able to connect your points. And I'm going to do my best to do this. I can, you know what, let me pull up my ruler here. And we are going to change this, and let me move it over so that I can use that to draw my line. There is my line through my points. Okay. And this is g of x. All right. So if we look, our y-intercept did not change. Okay. It still went through 0, 0. What did change is that now g of x is steeper than f of x. Okay. G of x is steeper than f of x. Okay. Now, what you might also want to pay attention to here, we'll come back to this in a minute. Why is it steeper? What makes it steeper? Okay. So think about that as we move on to this next one, and let's see if this one is also going to be steeper than our f of x. Okay. All right. So for our next example, example 2, our slope is negative 2/3. Okay. So again, our negative, we're going to go down and to the right, or we're going to go up and to the left. Our y-intercept is still at 0, 0. Okay. So we're still going to start at 0, 0 because our y-intercept is 0. But then from there, we'll go down 2 and right 3. We're going to do that again until we run out of space in this third quadrant. Okay, so we get 3 points on that side. We'll go back to our y-intercept. This time we're going to go up and to the left. Okay, up and left. So up 2 and left 3. We'll put a point there and then go up 2 and left 3 again. And one more time, we'll go up 2 and left 3. And now we can connect those points. Okay, I'm going to put my ruler there so I have a better way of making these straight. I should have done that with my 2 parent functions. Okay. Here is my g of x. Okay. Now, this one, we actually have 2 different translations or 2 different changes here. This time, we're reflecting it. Okay. We reflect over the x-axis. Now, x-axis. The reason we reflect it is because our slope has a negative, okay? The negative is what makes it reflect. Other than that, it is less steep than f of x, okay? So it's not as steep. It's not as steep as f of x, and it's reflecting, okay? Now, it might not be as easy to see that it's not as steep if we made it just a positive 2/3. And I'll change color here. So if we had started here and gone up 2 and right 3, and then up 2 and right 3, and one more time, you would see that it's not quite as steep as our parent function. Okay, and I'm just doing that one quadrant so you can see it's not rising up as fast as our parent function rises up. That's why we call it less steep. Okay, so what I really want to call your attention to on steeper versus less steep, if our slope is bigger than 1, then it will be steeper. If our m is between 0 and 1, it will be less steep. Now, I'm just looking at the number there, and we're not talking about the negative. The negative is going to be treated separately. The negative, all that's going to do is tell me that it reflects. Okay? The negative does not have any effect on whether it's steeper or less steep. It just reflects the line. Okay? So let's look at example 3. All right, so the graph of g of x is on the coordinate plane to the right. It's already graphed for us. And I don't really like where that label is, so I'm going to move the label down here. So this is g of x. They want us to describe the vertical translation and steepness change of the linear parent function, f of x equals x to g of x. So just so that we can make our comparison, let's go ahead and put our linear parent function in here. Okay, we're going to go ahead and put in our linear parent function. And remember, it starts at 0, 0 and has a slope of 1 over 1. So we're just going to go ahead and put our points in. And then we'll connect these points and get our linear parent function line in there. That way we can make a comparison between the two lines. It'll be easier for us to tell if it's steeper or less steep, or if it's moved at all. Okay, so let me go ahead and put my ruler up here so I can make this a straight line. A little straighter than what I would normally do here. Well, it seems that my ruler has gotten a little stuck. Here we go. All right. There we go. There's our linear parent function. We're going to call this f of x. All right. So as you can see, g of x, this line here, one that was already graphed, is not as steep as f of x. Okay. So this is less steep. G of x is less steep. But our y-intercept is still at 0, 0. Our y-intercept is still the same. Okay? So let's figure out what our slope is for g of x so we can write our equation. We can pick any 2 points we want. So I'm going to pick this point and this point, okay? The origin and then that -6, -3 point. So when we look at our rise, we're going up 3. And for our run, from -6 to 0, we're going 6 in a positive direction, 6 to the right. So when we do 3/6, that is going to simplify to 1/2. So g of x is 1/2 x. Now, if I want to write this in function notation form, g of x equals 1/2 f of x. Okay. Anytime I'm putting that 1/2 or that slope outside the f of x, that's going to affect how steep that line is, how quickly it moves from one point to the next. Okay. Now, when we change the slope, as I said, it changes how quickly we go from one point to the next. However, changing the slope does not affect the y-intercept. Okay? Changing the slope does not affect the y-intercept. And in the previous video where we were changing the y-intercept, we saw that changing the y-intercept does not affect the slope. So each of these are changes that are independent of each other. Okay, does not affect the y-intercept. So making it steeper or less steep does not affect whether it moves up or down. And vice versa. Moving it up or down does not affect how, making it steeper or less steep. All right. So let's look at if we're given a description and we need to write the equation for it. Okay. So we're changing it from f of x equals x from our linear parent function. Our linear parent function to g of x, and it gives us some examples of what g of x is going to be. Okay, so it has a slope of 6/5. So this is going to be our new m. M equals 6/5. Because remember, we're going to put this into g of x equals mx plus b. Okay, so our m is going to be 6/5. Our y-intercept is 2. So that means our b is going to be a plus 2. Okay? So our equation is going to be g of x equals 6/5x plus 2. Now, we can write this in function notation form as well, with f of x as part of our function. We write it as g of x equals 6/5 times f of x plus 2. It's the same equation, okay? Because our f of x is just x. But we're just taking the new intercept and the new slope and putting those into the equation. Now at 6/5, we want to look and see, is 6/5 greater than 1 or is it less than 1? Okay, just because it's a fraction does not automatically mean it's less than 1. Okay, anytime the number on top is bigger, you'll recall that is an improper fraction. That means that the bottom number can divide into the top number at least one time completely. So that means that it is greater than 1. Therefore, this g of x is going to be steeper than f of x. Okay? And that plus 2 means that it moved up 2. Okay? Because it is asking us to describe the changes. A is either being steeper or less steep, and B is being that it moved up or down. Okay? For example 5, our slope is 4 over 9. So our m is going to be 4 over 9. And our y-intercept is -1. So our b is going to be -1. So g of x equals 4/9 x minus 1. Okay? So 4/9 is a fraction that is less than 1. Therefore, this new line is less steep. Than f of x. And because it is a -1, it has moved down 1. Now, again, let's rewrite this equation in the function notation form with the f of x notation. So g of x equals 4 over 9 f of x minus 1. Okay? So we're taking the entirety of the function f of x, multiplying it by 4 over 9, and then subtracting 1 to it. All right, guys, that is going to do it for this lesson. If you have questions, put them in the comments, send me a message. For those of you that are watching in class, because this is my class lesson, you can ask me on Monday, and I will talk to you guys later. Bye-bye.